Hello, ladies and gentlemen. Today we're going to be talking about like terms. Specifically, what are like terms? And then, how can I use like terms to organize expressions and make them easier to solve? Excellent. So, first question, what are like terms? Well, like terms are simply numbers with the same variable and exponent. I'm going to double underline the word and because it's important. Because you're going to find a lot of terms may have the same variable, but they're not like terms unless they have the same variable and exponent. Just a reminder, a variable is just a letter that's next to a number. It represents an unknown number that we're going to be using to multiply later. And the exponent is, let's just take a look at this number here, 4x squared. The variable would be the letter x, and the exponent is this little number in the top hand corner. We'll talk about exponents in the future, but right now all you need to know, just for like terms, is that two numbers that have the same letter, variable, and the same exponent, little itty bitty number, are considered like terms. So I want you to look at this jumbled pile of terms here and see if you can find any other like terms with 4x squared, meaning any other numbers with x squared in it. Okay. Hopefully you were able to spot this 7x squared. Notice they're different numbers, but they have the same variable, which is x, and the same exponent, x squared. And negative 2x squared. Once again, different numbers, negative 2, 4, and 7, but they have the same variable, which is that x, and the same exponent. You may have been tempted to choose maybe 3x over here because you were thinking to yourself, well, Mr. Grapp, 3x, it's a different number, but it has the same variable. Look at that. They all have x. Aren't they like terms? And that's why we double underlined the word and. Because, yes, they have the same variable, but they do not have the same exponent. All of these have a 2 in the upper right-hand corner. This 3x doesn't have anything in the upper right-hand corner. Technically, there's a little invisible 1 in the upper right-hand corner. This is x to the first power. But we're mathematicians. We're lazy. We don't put the 1s there. You're going to see there's a lot of invisible 1s in math. But yeah, they have different exponents. Even if the 1 isn't there, there is no exponent. And so the exponent is, by nature, different. And so this is a different kind of like term. See if you can find the other two like terms with 3x. Great. Hopefully you found this negative 5x right next to it. Different numbers, same variable and same exponent, meaning none. No visible 1. And this 4x over here. Once again, different number, same variable, same exponent. Right? Perfect. What about these constants here, Mr. Grapp? What about these numbers, 7, 3, and 2? Do they count as like terms? Absolutely. They do count as like terms, and here's why. They have the same variable, which is none at all. They have the same exponent to that variable, which is none at all. The absence of those two variable and exponents makes them similar. It's like if I had someone if I was organizing people with wearing different socks. Like these red ones are people who are wearing both socks. These green ones are people who are wearing one sock. And these orange marbles are people who are wearing no socks. They are alike in what they are missing. So like terms, really, if you want to just keep it simple, like terms are just numbers that have the same thing after them. All these red ones have x squared after them. All these green ones just have x after them. And all of these orange ones have nothing after them. Like terms. So how do I use like terms in organizing my expressions? Well, before we can talk about that, let's just explain what I mean by organizing an expression. Right down here below, I've got two expressions. We're going to work on this left-hand side first. Very simply, mathematicians like to keep order and organization when it comes to their expressions. When things are ordered, they're easier to solve. And in this case, we have 2x plus 4 minus 3x squared. There aren't any like terms in this expression, but As mathematicians, we like to keep our letters to the left, meaning our variables to the left of an expression, and our numbers to the right. In fact, let me write that down because that's kind of important. We like to keep our variables or letters, vars, to the left of an expression, and our numbers to the right. It just helps with the solving process later in life. The sooner you can get that under your belt, the better. But, Mr. Grapp, this is an expression. Isn't it written in stone? How can I change an expression? Won't that change the value of my overall expression? And the answer is not at all, actually. Mathematicians have made algebra or studied algebra or discovered algebra, maybe is a better word for it, and have found that you can actually move any term in an expression and it'll stay the same value just as long as you take the term with the sign that's next to it. So if I wanted to move this 3x to the back, which I want to do, I want to move this 3x squared into the very back of this, I can do that, but I need to make sure that I lump this negative sign in with it. If I move the negative sign with it all the way to the back, nothing about the value will change. If I don't bring that negative sign in with it, then the value of the expression does change and I get an invalid expression. So let's move this negative 3x to the very back of our expression. Let's just do that. Negative 3x squared. Boom. I just moved it to the very back. And now I'll write the rest of my expression in. 2x plus 4. Hold on a tick, Mr. Grapp. You said it would be the same expression, but it feels like you're missing something here. 3x squared, 2x plus 4. Shouldn't there be a plus or minus sign there? I'm so glad you caught that. And the answer is yes, there should be a plus or minus sign. But which one? Well, to answer that question, we just look back at our 2x. Was this 2x positive or negative? Well, it's a positive 2x. So the sign that goes there is a positive sign. And just like that, I've moved the negative 3x over and have everything all nice and neat. I've got my variables to the left, my numbers to the right. Everything has its original sign, and we're ready to rock, baby. Great, Mr. Grapp. I can reorder expressions, but what do you mean by organizing for better and easier success? Well, let's take a look at this next one over here. We've got 3 plus 4x minus 2 plus x. There are some like terms in here. In fact, let me circle them for you. 3 and 2, let's use red. 3 and 2, those are like terms, or 3 and negative 2, I should say. Those are like terms. They don't have a variable or an exponent. And 4x and x, those are like terms. They don't have a exponent. They both use the letter x, so they are like terms. But notice they're jumbled up. I've got a number, then a variable, then a number, then a variable. I want to order them so that I have all my variables to the left and all my numbers to the right. So let's do that. Let's move all the variables to the left-hand side of the equation and all the numbers to the right. We'll start with this 4x, or rather this positive 4x. So I'll go plus 4x. And you know what? Let's cross it off just so that I know I've done it. Then I'll do that plus x over on the side. Cross that off. And then let's put this 3 here. It's a positive 3, so I'm going to put a plus 3. And then this is a negative 2, so I'll put a minus 2. Negative 2 minus 2. And there we go. I have reordered my expression. And now I've got a beautiful expression with all of my like terms next to them. In the next video, we'll discuss why we want our like terms next to each other, because we're kind of running late on this one as it is. But just know, bottom line is this. Like terms are numbers that have the same things at the end. They have the same variable and exponent. We can reorder expressions any way we like. We can move anything anywhere just as long as we move the number, like the whole term, along with its sign. And lastly, we like to reorder our expressions so that my variables are to the left and my numbers are to the right. And more specifically, so that I have all my like terms in little individual like groups. All right, catch you in the next lesson where we actually take this reordering to the next step. And and we combine our like terms.